The night sky appears ordinary until a stray glint threads across the sensor and refuses the script. No blooming coma, no confident tail, brightness rises, then ebbs, like a mirrored shard rolling in slow sunlight. The Comet template stumbles here, and that misfit is where this investigation begins. Public observations from multiple instruments sketch a shape defined more by what is missing than what is present. Dust should thicken, it does not. Volatile lines should flare, they stay faint. The track holds, yet tiny nudges along it hint at forces that are not just gravity doing quiet work. Audiences expect either a monster or a mistake. The truth is harder and more useful. When the usual model breaks, risk widens. Not because catastrophe is certain, but because uncertainty grows teeth. If this object is not a comet in the ordinary sense, what precisely is pushing it, and how close can that push bring it? This film follows the evidence. No proclamations, only tests that bite. Light curves, polarimetry, thermal whispers, and the silence of radio will stack into a picture that is stranger and potentially more consequential than a dusty snowball. Begin with the anomaly, then ask the question that matters. If not a comet, what operating rule is at work here? Routine sweeps start the record. Wide field optics stepping across a quiet star field, flagging a faint mover against a fixed lattice. Follow-ups tighten the astrometry, same stars, same plates. Cleaner fits until a path and pace hold within quoted errors. Photometry begins broad to catch flux changes, then narrows to watch color behavior. Every frame travels with its paperwork. Aperture, seeing, sky brightness, detector quirks. Claims are only as strong as the housekeeping behind them. When a body is a comet, expectations are plain. Nearer the sun, heat drives volatiles outward, gas and dust lift a coma that blooms, and a tail aligns roughly with solar wind pressure. Brightness usually climbs with decreasing distance, color reddens as dust thickens, and spectra light up with familiar lines, water, carbon monoxide, carbon dioxide, signatures of chemistry and motion. That is the template the observations are compared against. Not a story, a checklist. Observability is a gradient, never a switch. Phase angle can brighten or mute. Geometry can hide a tail or mimic one. Seeing smears the point spread function. Thin cloud etches, halos. Stacking suppresses noise but can smear structure if tracking stumbles. Signal to noise improves with exposure, yet background galaxies and faint field stars creep into apertures. Each of these is logged because a clean residual begins with a clean log. Teams answer with a fixed routine. First, lock the orbit, repeated astrometry across several nights to stabilize a gravity only fit. Second, sample the light curve with cadence that can separate rotation, aspect, and activity. Third, map color indices to sense dust, load, and surface clues. Fourth, sweep low-resolution spectroscopy to scout for broad features, reserving deeper integrations only if a line even whispers. Thermal context anchors the energy budget. If mid-infrared emission matches bare rock, one set of models earns a hearing. If it lingers like porous fines or layered crust, another set takes the lead. Radar, when geometry cooperates, bounds size and texture in a single pass. Polarimetry, often overlooked, reads the microphysics of grains, even when images look empty. It is the quiet instrument that speaks clearly about surfaces. Background, therefore, is not certainty, it is constraint. Instruments have floors and ceilings, the sky has moods, geometry plays tricks. The discipline is to state what a standard comet should show, state what the sensors can actually see, and record the gaps with the same care as detections. Only then can deviations be weighed, deviations from expectation, not from desire. From here, the documentary proceeds methodically. The template is on the table, the observing windows are known, the limits are honest. If the body conforms, the checklist will show it. If it does not, each discrepancy will be named, bounded, and handed to the next test. The background is complete enough for departures to matter. A small kink in the light curve forces a pivot. Flux rises and falls without settling into a clean rhythm, as if geometry and activity are crossing wires. The tail, expected to sharpen with solar approach, stays reluctant. That hesitation becomes the ignition event. When the Comet template falters, objectives are written down, testable, and timed. Objective 1, volatiles or not. If sublimation is the engine, gas lines must speak. Metric. Detect broad water bands and the common carbon species at credible signal to noise, tied to heliocentric distance and phase. Protocol. Scout with low resolution spectroscopy. Commit to higher resolution only if a hint appears. Falsification. A sustained scaling detection retires volatile. Poor models. A well-measured ceiling prunes gas, rich branches instead. Objective 2, dust physics in the open. Coma brightness, radial gradients, and phase behavior reveal grain size and production rate. Metric set. Multiband photometry for color indices across cadence, polarimetry for the scattering fingerprint. If polarization angles follow textbook dusty flows, surface facet hypotheses weaken. If they lean toward compact surfaces, the inference shifts to a crusted skin. Either outcome narrows the maze. Objective 3, dynamics under audit. Rumors of non-gravitational acceleration demand skepticism, then arithmetic. Metric. Residuals between observed astrometry and a gravity. Only ephemeris across an extended arc with catalog biases, timing errors, and seeing weights explicitly corrected. Surviving residuals are tested against solar pressure scaling. If the push grows with sunlight and aspect, high area to mass geometry enters play. If it vanishes, bookkeeping was the culprit. Objective 4, thermal context as referee. Mid-infrared flux, when the window opens, anchors the energy budget and surface inertia. Rock re-radiates fast, porous fines lag, mantled crusts complicate both. Metric, paired IR sessions at separated phase angles to map thermal lag and emissivity. A temperature curve inconsistent with a dust-rich coma elevates surface-dominated models. A warm, vent-linked trend argues the opposite. Objective 5, geometric truth. Phase, angle, aspect, and rotation can counterfeit activity. Metric. High cadence photometry to hunt periodicity, light curve inversion to test whether reflective facets can mimic cometary heartbeat. If a rolling shard reproduces the modulation without gas or dust, chemistry becomes a secondary suspect and structure moves to the front. Every objective carries a trapdoor. If water lines flare, volatile, poor scenarios fail. If polarization locks into coma behavior, mirror facet stories fade. If residuals flatten after bias control, extra forces dissolve. If IR warmth says porous fines crust, first thinking advances. The discipline is to publish these tripwires beforehand and step on them in view. Roles are assigned with a clock. Photometry teams own cadence and color. Spectroscopy teams chase dawn and dusk windows. A small dynamic cell watches residuals nightly. Another prepares a radar request for the first favorable geometry. Cross-calibration is its own objective. Shared flats and standards, overlapping fields, and a nightly ledger of sky moods to keep trends honest. Finally, The objectives are stitched into a decision tree objective metric instrument pass divided by fail. Next test. A positive here routes to deeper resolution, a negative there prunes an entire branch. The aim is not theatrical certainty, but a narrowing corridor where only a few explanations can still breathe. The ignition event lit the corridor. The objectives now build the walls. Cadence leads the sequence. Night after night, the object is walked across the detector with the same choreography: broadband flux, a quick color sample, and a precise note on geometry. Exposures are bracketed to keep faint signal and field stars in range. The intention is simple and stubborn. Let repetition suppress noise, so that behavior, not theatrics, drives the story forward. Anomaly 1 arrives in the light curve. Brightness swells and ebbs, yet refuses to lock into a clean period when the team attempts phase folding. A tumbling shard with patchy albedo could do this. So could low-level venting that flickers with heating. Uncertainty is ordinary here. Thin cloud, seeing that breathes, and calibration stars that age poorly. Cross-calibration is ritualized until the wriggle remains. To separate facet from jet, cadence tightens. Shorter exposures raise sampling density, and harmonics are hunted across several nights. Simulations generate rotational curves for elongated bodies and compare residuals to a venting template with stochastic flicker. If the added cadence reveals nested periodicities, geometry moves up the suspect list. If not, activity keeps a seat at the table. Anomaly, two concerns: coma and tail that will not read the script. Closer to the sun, a classical comet should advertise itself. Instead, coma stays tentative, and the faint extension refuses to align cleanly with solar wind pressure. Geometry could be the culprit, with a low dust yield distorted by phase angle. Deep imaging and radial profiles test that conservative reading. Profiles are azimuthally averaged to crush background texture. If a true coma exists, its wings should thicken beyond the stellar point spread function. When the wings remain thin, the team writes an upper limit on dust production rather than a paragraph of adjectives. Limits travel better than rumors and will weigh more heavily in the models to come. Anomaly 3 is a whisper of non-gravitational push. Orbit fits improve with every night, yet small residuals survive a gravity-only ephemeris. Before calling physics, bookkeeping is audited line by line. Catalog biases, clock errors, and the weighting of marginal seeing are reworked. Residuals that survive this gauntlet earn a thought experiment about sunlight and area to mass. Numbers are sketched in full view. For the measured offset, the implied ratio is ordinary for foamy fragments and unusual for monolithic rock. The prediction is crisp. If radiation pressure is guilty, residuals should scale with heliocentric distance and aspect. The plan is patience. Watch the pattern across a longer arc and let the scaling either sharpen into law or dissolve into noise. Anomaly 4 is the quiet of spectroscopy. Low resolution sweeps across the neighborhoods where water and carbon species usually speak, return nothing above threshold. Silence is logged as a ceiling, not a shrug. At the achieved signal to noise and aperture, any production above a stated value would have been seen. Entire gas-rich branches of the Comet family tree are pruned by that single line. Alternatives proliferate with discipline. A volatile pore surface, a mantled crust that chokes vents, or a reflective skin that boosts optical brightness without feeding lines all fit the quiet. The next test climbs the ladder. Longer integrations, narrower filters, and co-added nights tied to thermal peaks. A single credible rise would demote the crust story. Sustained silence promotes it. Anomaly 5 is a thermal personality out of character. Mid-infrared observations return a soft, cool signature. Thermal inertia looks low, consistent with fines or layered material, yet the coma limit argues against a drifting cloud. Reconciliation sits at the skin. A crust welded with bright fines can reflect in optical and lag in infrared without releasing a visible veil of dust. Modeling earns its keep. Temperature curves are fit against rotation, phase, and emissivity assumptions. The team asks whether the thermal phase curve bends like bare rock or like layered crust. If the curve refuses both rock and free dust, the case for a mantled surface rises. Geometry becomes a tool again, with sessions spaced to sample contrasting phase angles. Anomaly 6 is solar wind without a tail. Narrowband imaging for common ion species returns little. A calm wind could excuse the null. A gust would make it louder. Imaging is coupled to in situ solar wind data, so the silence can be graded. The next observation is timed to a predicted feature. A correlated response would soften the null, while an anticorrelation would make it shout. Anomaly 7 lies in dynamics that dislike comet clubs. The Tisserand parameter and backward integrations place the object awkwardly among familiar families. That does not grant identity, it subtracts default comfort. A capture and reshape pass or an evolved fragment could have wandered into this lane. Statistics, not slogans, will tell whether such wanderers are rare or merely overlooked. That statistical path is long but straightforward. The orbit is folded into population models, and the fraction of volatile poor bodies expected to occupy this space is estimated. Low probability is not impossibility, but it is a flag. Flags do not convict. They instruct. They tell the team where more precise astrometry and longer baselines will pay compound interest. Anomaly 8 is a polarimetric eyebrow. When images look empty, polarized light still speaks about microphysics. The polarization phase curve leans away from the textbook signature of fluffy coma grains and toward compact reflective surfaces or sintered skins. Calibration is unforgiving. So the result is replicated with independent hardware and standards injected into the night. When the curve holds shape across systems, confidence accrues. A coupling test follows, tying polarization, swings to suspected rotation. If swings track a repeating aspect, reflective facets become more than a metaphor. If they do not, a compact, rough surface without mirror-like patches moves up the list. Either way, the dust-driven narrative weakens. Across the 8 layers, a pattern emerges without proclamation. Each negative result narrows the corridor. Each tentative positive points to the next lever arm. The silhouette is a body brighter than its gas, cooler than its dust, and unusually sensitive to sunlight for its mass. That is not exotic by default, but it is operationally meaningful. Method becomes message by design. Every finding is followed by a caveat, an alternative, and a named next test. Light curve flickers, calibration is checked, geometry competes with jets, cadence tightens, tail resists, geometry is modeled, deep profiles run, limits are published. The repetition is not padding. It is how fragile clues survive skepticism long enough to matter. Priorities shift accordingly. Another week of dense cadence may buy more than a heroic marginal spectrum. Polarimetry at new phase angles is cheaper and sharper than speculation. A single radar ping, if geometry smiles, would collapse uncertainties on size and texture in one stroke. Budgets are steered by this logic, not by headlines. By the end of the sequence, the Comet template is stressed rather than shattered. If outgassing exists, it is meager. If dust moves, it does so with discipline. If a push remains, it looks like sunlight on surface rather than jets in vacuum. Names do not control risk, behavior does. Small forces, integrated over long arcs, change lanes that matter. The anomaly stack closes like a funnel. Into it go the remaining models: volatile, poor crust, high area to mass fragment, rubble pile with reflective finds, and the speculative artifact hypothesis kept on a short, testable leash. Evidence has tilled the ground. The next part will force those models through the narrow throat and see which ones breathe on the other side. Silence becomes a measuring tool when it is written down. Spectra sweep the neighborhoods where water and carbon lines should rise, and nothing clears the bar. That nothing is not a shrug. It is an upper limit with units, aperture, and signal to noise attached. Any model that needs more gas than that ceiling now argues uphill against the record. Deep imaging is equally restrained. Radial profiles that ought to bloom into dusty wings stay close to the stellar point spread function even after stacking and azimuthal averaging. The shape of that thin profile caps grain production and the sizes that could have escaped. With one plotted curve, entire gas-rich branches of the Comet family tree are trimmed. Meteor history has asked a different question. Is there a shower, even a faint one, that follows this orbit? Catalogs answer with a long pause. No link stream appears, which does not prove serenity, but does weaken the case for a body that has shed generously over time. If mass has been lost, it has been recent or ruthlessly disciplined. Radar is geometry's hostage, and windows often miss. A missed return says little, but when a decent window opens and the echo still refuses, that no bounds size and surface roughness in unglamorous, powerful ways. A small, smooth cross-section can slip the beam. A rough, bigger face would not. The silence fences parameters without a single dramatic image. Polarimetry carries its own quiet. When polarization angles decline to match the signature of fluffy coma grains, weight shifts toward compact surfaces or sintered skins. Replication matters here. Independent hardware, injected standards, repeated nights. When the curve holds shape, the silence presses not to a verdict, but to a surface-dominated interpretation. Operational quiet also counts. No broad alerts, no dramatic reversals, only steady cadence and plain memos. In an ecosystem that rewards noise, the lack of alarm is itself information about confidence and caution. It implies the corridor is narrowing, not collapsing, and that each added hour of observing buys real leverage. Bayesian bookkeeping gives these voids a home. Priors drawn from the Comet template meet likelihoods shaped by nulls, and the posterior slides toward a body with meager vents, bright facets, and behavior more sensitive to sunlight than vapor. Design follows from that shift. Longer, narrowband integrations at thermal peaks, polarimetry at phase angles where silence would be loudest, tail searches gated to solar, wind weather. Here, what is not seen prunes what can still be true. Provisional answers arrive as contours, not monuments, faint, conditional, and carved by measurement. The corridor is narrower now. What remains must explain quiet gas lines, disciplined dust, a light curve that hints at facets, and small residual pushes that seem to track sunlight. The task is not to crown a winner, but to rank what earns the next hour of telescope time and what can be retired with one clean test. Model A, volatile pore or mantled crust. An object once icy may be sealed by sintered fines or irradiation, reflecting well, venting poorly, and shedding so little dust that a classical tail never commits. Predictions: weak or absent water, divided by CO lines, polarization nearer compact surfaces than fluffy coma, and low to moderate thermal inertia with a phase-dependent lag. Falsification: A sustained rise of gas lines with solar approach or deep profiles that thicken into textbook dust wings. Model B, high area to mass fragment. If sunlight pushes more than jets ever could, a broad, thin geometry, natural shard, foamy aggregate, or plate-like debris can fit the residuals. Predictions. Non-gravitational accelerations that scale with heliocentric distance and aspect, microglints in dense cadence, polarimetry leaning towards smooth facets, falsification, residuals that vanish after bias control, or trends that refuse solar scaling over an extended arc. Model C, rubble pile with reflective fines, a loosely bound aggregate, dust poor externally but coated with bright micrograins, can mimic high albedo without venting. Predictions. Low gas lines, subdued coma, a polarization phase curve intermediate between rock and dust, and a cool yet laggy thermal personality. Falsification. Radar or occultation exposing a compact monolith with smooth skin, or polarimetry that snaps to canonical coma behavior at new phase angles. Model D, techno-artifact, edge hypothesis. Prior probability is small. The evidentiary bar is high. Predictions must be concrete. Coherent specular returns, repeating with engineered regularity, narrowband emissions inconsistent with known geochemistry, or spin behavior suggestive of control rather than passive torque balance. Falsification is cheap. Demonstrate natural acceleration scaling, natural thermal emissivity, and stochastic not regulated light curve features. The decision matrix is explicit. For each model, current, fit to data, cost to test, time to resolution, and failure, value what is learned if it is wrong. On that grid, A and C lead for immediate scrutiny, best overall fit with affordable near-term tests. B remains in contention pending a longer astrometric arc to lock radiation pressure scaling. D stays as a low prior sentinel, explicitly testable, quickly rejectable, never a narrative shortcut. Risk is framed in familiar statistics. Type I error, overcalling danger burns, aperture, attention, and trust. Type 2 error, undercalling it forfeits early warning if a high area to mass body drifts into lanes we care about. Operations accept a deliberate asymmetry. Modest vigilance, keep cadence tight when geometry pays. Preserve observing windows that test the scaling laws, and insist on language that matches evidence. Actionable steps follow from the matrix. Photometry. Increase cadence around phase angles that maximize facet signatures and search for harmonics that betray rotation, aspect coupling. Polarimetry. Book 2 contrasting geometries to test the compact surface interpretation. Spectroscopy. Commit to deeper, narrower integrations for H2O and CO ladders during thermal peaks. Mid-IR. Secure 2 phase separated sessions to pin thermal inertia. Radar. File a contingency ping for the next favorable geometry. Cheap fast experiments by leverage. Coordinate a multi-longitude ring for near-continuous light curves across a full surrogate rotation. Share calibration stars to lock 0 points and pre-register reduction pipelines so tweaks cannot drift toward a favored outcome. Publish upper limits in near real time alongside detections so nulls do not vanish into private notebooks. Silence should weigh as visibly as a line. Governance matters. A public log of objectives, thresholds, and trapdoors keeps the process falsifiable while it moves. Cross a pre-declared trigger, for example, residual accelerations that scale with sunlight over weeks, and resources pivot automatically to dynamics and thermal follow-up. Miss the trigger, and the plan ratchets down without drama. This prevents hype from reallocating scarce hours that data have not earned. Provisionally, the weight of evidence leans toward a surface-dominated object, model A or C, with a conditional contribution from B if a high area to mass geometry hardens under longer arcs. In that blend, danger is not a headline, but a function. Small forces integrated over time can redirect trajectories in meaningful ways. The next window will decide whether sunlight merely paints this body or quietly steers it. The conclusion stays light on its feet. Every preferred scenario keeps a built-in exit. One credible line can revive venting. One disciplined scaling law can elevate radiation pressure. One sharp radar echo can collapse size and texture uncertainties in a single stroke. The value here is not a dramatic label, but a working forecast that updates on contact with the next frame. The next window opens in geometry, not on a calendar. As phase angle tilts and heliocentric distance shifts, small signals widen. Photometry will run dense cadence over a full surrogate rotation, hunting microglints that would betray facets. Polarimetry revisits two contrasting phase angles where a compact surface should swing its signature most. Mid-infrared sessions will bracket thermal lag with paired observations. Spectroscopy will trade breadth for depth. Narrow bands on water and carbon ladders get longer integrations, co-added across adjacent nights, and time to thermal peaks where faint lines are likeliest to wake. If nothing rises, those quiet frames harden ceilings that already prune gas-rich models. If a modest feature appears, it will be tracked against solar distance to test venting versus reflection. Cheap, fast experiments add leverage. A ring of small telescopes across longitudes can stitch near-continuous light curves without great aperture. Shared standards and overlapping fields will lock 0 points, so trends live in the sky, not in the pipeline. Synthetic injections, fake lines, counterfeit glints enter blind reductions to smoke out unconscious tuning and keep results falsifiable. Operations will tie observing to the weather of space. Solar wind forecasts will gate narrowband tail searches, so a null during a gust weighs more than a null during calm. When favorable radar geometry appears, even a single ping can bound size and texture sharply. If stellar occultations emerge, a brief star blink can fix silhouette cleaner than hours of noisy imaging. The decision table stays public and mechanical. Cross a pre-declared threshold, residual accelerations that scale with sunlight over an extended arc, and resources shift automatically to dynamics and thermal follow-up. Fail to cross them, and the plan ratchets down without drama. Trapdoors first, interpretations after. That is how the story remains testable while it moves. Reflection is the last instrument. A body that resists the Comet template is not extraordinary by that fact alone. But uncertainty clustered around dynamics and surface physics widens the risk envelope we must model. Evidence comes before belief, and belief must be light enough to be moved by the next frame. The sky will either break the model or bend toward it. Both outcomes are knowledge. If this inquiry matters to you, stay for the next observation window. Subscribe so updates arrive with data, not rumor. In the comments, name the falsification test you would trust most: a scaling acceleration, a thermal phase bend, or a late rising line. The questions are simple, the answers are earned.